Hello and welcome everyone, and thanks for joining us in this special show of Let's Talk About Data Show. Today we have an extraordinary topic to talk about, and we have legends in house. My name is Ibrahim Amara. I'm a database specialist solutions architect here at AWS, and I'm based out of London and one of your regular hosts. And today, as I mentioned, we have an extraordinary topic to talk about. We are going to talk about MariaDB innovations, and for that, we have a special guest today, Monty, the creator of the MySQL database and MariaDB. And he's not only a database developer, but he's also a visionary person who has fundamentally changed how the application is being built. And if you have ever worked with the LAMP stack, I'm sure you will relate to that. Monty, thank you so much for joining us today. It's a great honor to have you.
Thanks. I'm happy to be here.
Thank you so much. And from the AWS side, joining this historical discussion, our director of the RDS open source databases Jignesh Shah. Jignesh is leading the team who is responsible for the making all the innovations in the open source databases available for millions of AWS customers. Jignesh, thank you so much for being with us today.
Thank you. It's a pleasure being here.
And last but not least, my colleague and teammate, Simon Stewart. He's also a database specialist solutions architect, and he's not a stranger to the show. Simon, thanks for
True.
yeah. So, without any further ado, the topic that we have today is talking about the MariaDB innovations. But before diving into the technical details of MariaDB, Monty, let me just take you back in history briefly to 1994, I believe, when you started working on developing MySQL database. So around that time, there were many other RDBMS engines available. Some of them were commercial databases, some of them were open source databases. But for particular reasons, you have decided that it's time to work on a new database engines. What were the gaps that you have spotted and you felt like, yes, we need a different engine?
Okay, so actually the project started around 81, where I created a software who you can develop applications. And the reason for me creating MySQL was that I have a customer who was using this one. They were connecting to our computers with modems to get access to the data that we refined for them. And they wanted to have this new thing, the internet. So I created a SQL on top of my old code because I thought that SQL would be very easy to embed into web pages. I mean, this was before PHP, before most things. So you had, I mean, Perl was the most one of the most used accessor for creating web pages. So I did a kind of a trivial PHP for that. But that was because customer demands, and also that the other reason was that me and David Axmark, the second founder of MySQL, we always, since 83, had been used free software. And we always thought that it would be nice to be able to give something back to the community for all the tools that open source had created for us. So with MySQL, we thought that this is the first project that is useful for the masses, and we also come up with a way to commercialize that. So we were the first one who, we were the second program to use dual licensing, and the first one who in 2000 used it on GPL. And the reason for that was that we really believed in MySQL could become something, and we wanted to be sure that if by some miracle we actually would be popular, we actually had a way to grow and compete with the big guys. So we had a license that guaranteed that about 1,000 would pay us something. And if you have millions of users, or actually at some MySQL has had at some point 800 million users. That's still a good deal.
Yeah, definitely. And Jignesh, you've worked for Sun Microsystems before, and around that time when the MySQLDB acquisition took place, you were working there. So was that the first time that you being heavily involved with MySQL database, or you worked before that with MySQL database?
Yeah. So slightly before the acquisition of MySQL by Sun, I was working with open source databases, both MySQL and Postgres, primarily to kind of like optimize them for Solaris operating systems on Sun,
Mm.
which is where we worked heavily with the community to kind of like integrate them. And um, you know, MySQL had that special place because it was one of those easiest databases to run on it. And I think Monty had a rule like you should be able to do everything within 15 minutes, which I found to be like very inspiring because it really sets the standard of like say, hey, if you can do something, it has to be within 15 minutes that's usable. Otherwise, like you're making it too hard.
And the
Yeah.
50 minutes included loading it over a modem.
So 13 minutes for the uploading and then 2 minutes to developing it. So yeah, I totally agree with you, Jignesh, because I remember the first time I worked with the MySQL database and how easy it was to set it up, to just install it and set it up and start working with it compared to the other um, commercial databases that I've worked with. That was a totally different thing. Of course, in addition to the other innovations that we'll be talking about. But let me first ask you, Simon, because I know that since ever you've been working with MySQL and
I
MariaDB.
wouldn't say since forever. I think out of the three people here that works with MySQL or Maria, I'm definitely the baby of the group. So it's forever for me, but it's not
Yeah,
forever
I
compared to
mean for
everyone else.
you, yeah. Yeah, since I believe since you started working with AWS, you've been
Pretty
working
much.
with Okay, perfect. So, Monty, back to you. Talking about the innovations within MySQL that later on became even evolved more within MariaDB, which is the pluggable storage engines, and that's a unique feature. To be honest, I've never seen it with other databases before. But how the idea came to you to have different pluggable storage engines within the same engine?
So that also was that I was, let's say, like most developers, I'm lazy. So back then on this project before MySQL was called Unireg, uh, um, I had customers using it, and I was using a library from a Swedish company for the storage. And then the company said that we're not going to support it anymore. So I
Mm.
wrote my own MyISM library or ISM library, and but I didn't want to go to every customer to and have them upgrade to the new one because that's hassle. So I thought that okay, let's have both the old and the new work side by side, and then over time they on different engines, so it was kind of natural to just add an interface to do that. So it's just easy upgrades. I always love easy upgrades for applications. So and that also this also allowed me to very easily add in memory table because it was just the same interface. And now we
Yeah,
have a MyRox S3 in a DB and lots of other agents, federated. Okay.
exactly. And that also confirms to the modularity that the Linux is offering, having different modules, and then you can use whatever you want to, giving you the flexibility and also giving the end users this such flexibility as well. Because as you mentioned, in MariaDB right now, there are different storage engine other apart from the ones that you started with, the MyISM and InnoDB. So if you can uh, uh, talk to us about the other engines, that the storage engines that you have right now in MariaDB as well, and the use cases for each one of them, that would be great as well.
Yeah, but first, a difference with other databases. So
Yeah.
Postgres has this foreign key, not foreign key wrappers, but foreign database
Data
wrappers.
wrap.
Yeah, and they are really good for getting access to data, but they are not optimized. So the difference between our storage engine, the optimizer have full information about all cost and everything else, and all the capabilities, so that we get a much tighter interface. It's a little bit harder to do a storage engine, but you get much better performance
Mhm.
of it. So what we the most common one used is InnoDB, which is a transactional engine, um, very high performant. Then we have the memory for temporary tables, or if you just want to have something cached. Then we have area that is for internal temporary tables. Um, for example, if we do a group by and we need to store results, that is an area because it has a faster path for storing than InnoDB, because it can switch between transactional and non-transactional. And for temporary tables internal, you don't need transactions. Then we have MyRocks, that is same as what Facebook is using when you have uh, lots and lots of data and you want to have a really high compression because you want to save on machines. So Myrox compresses about 5 times compared to InnoDB. And if you have thousands computers and you get that down to 200, that's a big saving. It's also very good for short transactions. And then we have S3 that is used for archiving. It's very common in financial environments that you want to store all data, but you want to store them in a cheap storage and not together with your other data, uh, because you're going to access them much more seldom. So having a partitioned engine, and then you store part of those tables as S3. You kind of get the best of the both worlds. The S3 has all the same index capabilities as area, so it's really, really fast. And actually, it's much faster than anything else, just because it can cheat, because it knows that this is read only. So you can skip a lot of verification checks and other things that for example, concurrency, there's no problem because everybody can read anything at any point. That's
Perfect.
the most common one. And then we have column store if you want to have analytical data.
Yeah, for that one, so the entire data is being stored in a columnar fashion instead
Yes.
of the okay. And then when they are being loaded into the memory, they are still being accessed in the same way or being stored in the same way.
That's the benefit of the storage engine. The upper level doesn't need to know anything. It just
Okay.
asks column store, here's the where clause, give me the records. And column store uses the columnar indexes, or kind of indexes, to find the data, and then provides it back up to the upper level in row format. So that makes things much simpler.
So when we are talking about the memory structure itself, it doesn't have to know anything about the underlying storage. So
And that's the biggest benefit of the storage engines, because sooner or later, when you're looking at performance,
yeah,
everything comes down to how things are stored. You can have different uh, indexes, different uh, ways to access data, and uh, the storage engine hides that nicely for the upper level. It doesn't need to know. It only needs to know what features do you provide. For example, InnoDB provides foreign keys, and the other ones doesn't. So we have a flag that says this can handle foreign keys, and
okay,
so
perfect. And Jignesh, as a director of the RDS open source databases, uh, I'm sure that you have several discussions with the customers, Amazon customers or AWS customers, and usually at the decision maker level. And when they are discussing the benefits or how they are going to use or which database is more suitable for them, what are the benefits that you are highlighting if you are going to recommend MariaDB for them as
Mhm.
an open source database?
Yeah. So, I mean, the first thing I want to mention is, especially with Amazon RDS, we provide a choice to our customers related to the selection of their databases. And the choice could come based on their skill sets that they already have existing, their application dependencies that they need to use. And we allow them to be successful using those choices on RDS. When it comes to MariaDB, I think what customers like about MariaDB that I've heard firsthand from the customers is, you know, compared to the other open source MySQL versions of it, they often see performance improvements when they move to MariaDB out there. Plus, I think on the most recent versions, they have more features like vector support, which actually now is available for MariaDB, even on RDS. So they see more features. And similarly, they also have ways to kind of like leverage, as Monty mentioned, about different storage engines. So even on RDS, we support the Rocks, my Rocks engine out there. So they have a choice to kind of use that. What customers do like about that is that compatibility between MySQL and MariaDB. So oftentimes the customers find it very easy to kind of like move from MySQL to MariaDB without making much application changes also. And then as they kind of like also get a chance to kind of use the features that MariaDB community provides them. So in all, I think it's a win-win for both the customers as well as the MariaDB community, and for us to kind of like provide that choice out.
Perfect. Thank you. And when it comes to the different features that are being developed in MariaDB, what are the criteria that you are using in order to prioritize making those features available on RDS as a platform?
Mhm. Yeah, so I think with every major version of MariaDB, we look at all the features that are supported out there, and then we work with the customers on how they are going to use those features and provide a way to kind of safely provide those features for our customer. Just to kind of give you, our tenant is like, security is your job number one
Of
when it
course.
comes to relational databases or any of the AWS services out here, which means our job is to make sure we provide the easiest way to use these features in a secured way on our managed database offerings. So the security aspect of that is the value that is actually provided along with those features out there. Our aim is to kind of like support every native feature that is in MariaDB that can be used by our customers with minimum limitations of when it comes to kind of like what we can provide in a managed offering with the security around it. So, uh, you know, I'm actually happy to say our engineering team was very heavily involved in the development of the vector feature, working with Monty and other DB community contributors out there in order to kind of like do the testing of the feature while it's actually being worked in the community. And when it got released in 11.8, it became part of the service also along with the major version support.
Perfect. Thanks, Jagnesh. So, Monty, just back to the point that Jagnesh mentioned, which is the security, because there's always that fear when we are talking about open source software that the security, the fear of security breaches, because you have access to the code itself, and that for some people will think that it will make um, the things from security perspective more difficult to secure the database or the software itself. So from MariaDB perspective, how you're making sure that security is also something that is no breaches, no security breaches, something like that. How you do the security checks on the database engine itself.
Okay, so the benefit of when you have millions of users, and I think that we are up in some 500 million MariaDB users now. Of course, not all of those are DBAs, but we have lots of people who are in or outside of MariaDB Corporation and Foundation who is very sensitive about their data. So we have lots of people checking commits and everything else. So even if we do everything we can to make things secure, and we put security really first, we still have other people who are looking at what we are doing, and we have very few security breaches. Uh, uh, if you think about anything where data actually can be stolen, uh, except for bad configurations,
Yeah.
I think we had 10, 15 years ago, we had that our hash was not secure if you could get access to the internal tables itself, which you should never do. But we had some issues there, and we have fixed that. So now we are uh,
Perfect.
really good, and we have expert checking our logic and agreeing that this seems to be safe. We also one of the few databases, maybe the only database who has SSL by default. So even if you don't configure MariaDB, and this is from 11.4 forwards, even if you don't have SSL configured, we will still use SSL. So we will create an artificial certificate and force the client to do that. He basically have to say skip SSL to not have that. And this is the reason for that is that uh, if you don't have that, you are open for a man-in-the-middle attack, because the user can know if the database is secure or not. So somebody can be in the middle and say, "Oh, we are not secure, don't care about it," and then you can steal things. So
Great.
we fixed that in
That's
about
perfect.
1.5 years ago.
That's great. And sorry, Jignesh, go ahead.
Yeah. So one thing I would really want to add, like, the fact that it is open source allows the scrutiny by thousands of researchers
Mm,
out there, and that actually helps in kind of like flagging of any problems by any of these researchers early. And because there are number of contributors working with MariaDB, it also gets like fixed quickly, right? So I think the overall open source nature of it is very beneficial.
agree.
And the last thing is what we noticed that very early with MySQL, because MySQL, when it became popular, lots of the companies were writing C or C++ checkers and both analyzes the code for finding security. They all used MariaDB and MySQL, and then MariaDB as the base thing to test with. So we got lots of reports from these
Mm,
researchers, and we are fixing anything that is relevant. So that's kind of a benefit when you are popular.
exactly. Yeah, agree. And Simon, because as Monty mentioned, it's again apart from what they threaten within the code, it's the configurations, your configuration, how you are securing your data. So what are the best practices that you are recommending for the customers when they are running MariaDB on RDS?
So Monty's already kind of touched on a couple of these already with SSL, but SSL being one, encryption by default everywhere you can. That can mean up to and including encrypting the data itself. But I mean, at a minimum, you probably want SSL for encryption in transit, and you probably also want encryption at rest as well. Ideally, you want to minimize the scope of what can connect to the database and the permissions that it has when it connects to the database. So, for example, you don't want a security group that has allow all for any host in the world, for example. You want to keep it dedicated to a private subnet. You want to only allow certain machines in that private subnet. And then you want to control what user can connect and what they can do when they connect. Because realistically, if you can run a select, you can basically run a select star on something and dump it locally. And let's hope you don't lose that laptop. So, yeah, be careful who can connect, where, when, and why.
I would add to that the most common mistake I see people doing in web applications, they basically give everybody rights to everything. Instead of having that those who searches, they should only have select privileges. And then only when you go to actually doing transactions, then you change to another user who has the privilege to do that. That makes things much more secure.
Perfect. So moving to a different topic, which is replication. Because based on the discussions that they usually have with Simon, replication is something that was not that very straightforward also has some complications in MySQLDB, but I know that there are some or major improvements took place for replication on MariaDB when then talking about the parallel replications
Yeah.
and parallel threads. So can you give us more details about that, please, Monty?
Yes, we have been lucky to work together with Christian Nielsen many years, and I would say that he is one of the leading replication experts in the world, and he was the one who helped us, who actually implemented the parallel replication for us and many other features. He know in foundation and continue with doing that. So I just want to finish the sentence. He's working on something that is really cool, and that is that when you have a transaction database and then you also have an application stream, you need to sync both to the disk the whole time to keep things consistent. I know he's removing one of those things, and that will give in 12.3, depending on your hardware, 25% minimum, but up to 10x speed up your application. So that's almost as much as you get from parallel application if you're running on hard disks. So parallel application allows us to group together transactions on the slave, and then run all of those in parallel. And then if everything succeeds, we just commit everything at once. Otherwise, we roll back those where there were conflict. But because we always guarantee in the application that the things are committed in exactly the same order as on the master. And there's a lot of databases who doesn't do that. For example, MySQL with group replication, initially they did not do that, and they got wrong results. So now they have that as default. But
Exactly.
it can actually speed up replication so much that the slave can keep up with the master, which
And
is
that's
what it needs to be.
and at the same time keeping the consistency, as you mentioned, the order of the commit of the transactions.
Yep.
Perfect. And Jignesh, such replication or the other options that we have for not only for the replication but the high availability features that we have for MariaDB on RDS. Can you please give more details about that as well? How it's being
Sure.
implemented?
So on RDS for MariaDB, we have, I would say, two styles of availability things that you can do. One is the inbuilt, what we call as the multi-easy availability for RDS MariaDB, which uses a storage replication type of thing, where you get like a sync storage for every write that you do on two of the ASs and gives you that protection at the storage level. Also, at the same time, for disaster recovery purposes, you may still want to kind of like have a replication to be done across regions of that. So we also support what we call as like the bin log replication of that. So you could use it from your RDS MariaDB bin log replication to another MariaDB server running in a different region. Or maybe you could also do that in region if you want through a simple click and deploy type of options of that. So as part of the managed services, we also allow you to kind of create read replicas that you could create in region as well as like across regions out there. So the across region ones is actually used quite a bit for like a disaster recovery purposes out there. So with this type of things, we do provide high availability for MariaDB out there. Personally, I would actually give you one more use case where we use this replication. That is part of our RDS blue-green deployments.
Mhm.
Where if you want to make like change management for your databases, we use the bin log replication to kind of create a new green setup. And you can make all your changes on your green setup. And when you're ready, you could do a switch over to that green setup. Personally, I'm actually a big fan of the bin log replication that MariaDB uses because it supports even the DDL type of changes. So you can do schema changes and it gets replicated on the green setup. and then you could actually continue to kind of do those applications and be ready to switch over as needed. So I think the replication technology is definitely in a lot of ways game changer for us to kind of create innovative use cases for our customers.
Yeah, I think the key word to describe it is flexibility. It lets you do lots of different things in a way you kind of want to do it. It enables things.
Yeah.
Monty.
So I think that looking at other databases, for example, Postgres is also a great open source database. So one of the biggest differentiator is the way that we do replication. We have been logical from the start, but it's also designed that we can have different storage engine on the slaves. For example, we can have one big table on the master as InnoDB, on the slave is in column store. We can also do ring replication, and we can do star replications, things that nobody else can even think about without getting a headache.
Yeah. So even from the same source, you can replicate to different targets, and each one of them can have different storage engines as well.
Yeah.
So they can
And,
serve
and,
different
and
purposes.
replicate back.
And that's the one that was giving Simon headache, the active replication, or the bidirectional replication actually. It's because usually the challenge is how you're going to resolve the conflicts resolution.
Yeah, but normally we don't do conflict resolution yet. The actual project now just started, where we'll add that by triggers. But the thing is that there's quite often that you have, for example, on Yahoo, I think it was Yahoo, who had different databases, same table with different data on the east and the west coast. So they ensure that there were no conflicts. And if no conflicts, then you can have one replicate one way and other replicate the other way, and get full performance on both sides.
So you basically at the application level or the business logic there, you are making sure that there is no conflicts between the two separate entities or something like that.
Yeah, or we can also we have an option with two variables. We can ensure that auto increment on one node is always even, and other one is always odd, and that means that those you can replicate. The same thing with sequences. You can do the same thing with those, and you basically have a factor that you say what's the increment or what's the offset. So you can have any amount of nodes in the cluster without any conflicts with primary keys.
I see. And talking about the sequences and the auto increment, I've read that it's being implemented in a different way in MariaDB.
As far as I know, we have fully supported the full standard for sequences in MariaDB, but it's implemented so that you can have the sequence in any engine, because we want to have everything engine independent. So you can also look at when you create a sequence, you can look at the table, and it looks like one table with one record, and that's good for backups. But when you use it as a sequence, it works exactly the way that you expect it to work.
I see. Got it. And Simon, for your customers who are working with MariaDB, have they noticed these improvements in replication when they move?
In general, I think people have noticed replication performance improvements over time. I think historically, if you go back kind of 5 years, even 10 years, the kind of main kind of limiter of replication was single-threaded performance. Then it moved to kind of multi-threaded. Then it kind of got better parallelization of multi-threaded. And conversations around replica lag now tend to be an exception, as opposed to kind of 5-10 years ago, where conversations about replica lag used to be a frequent occurrence, where you'd have them pretty much daily.
And one thing that we've seen customers use more and more, they add also delayed replica. So they have one normal slave, and then you use replica. In Finland we use slave, and then you have another replica that's either connected to the slave or the master that is delayed with 2 hours. So when an administrator drops the wrong table, you have it on the delayed replica, which is very convenient. And with multi-source, you can even have the replica being backup of all your different databases
Okay. Yeah.
from different servers, as long, of course, that you don't have conflicts or you use different databases for those. That's very nice for backups.
Yeah. Definitely. And talking about the new innovations in the hardware, so something like the not that new, I mean, but something like the NVMe and the persistent memory. How MariaDB is leveraging hardware like that, or the hardware features like this, NVMe's and
So persistent memory, we used to work with the Intel with these Optrons, and but then they um, lost the rights to those. So we haven't seen a really good replacement for that yet. There's lots of things talking about that is coming. So what we do have an option that we can store the uh, end of the binary log in persistent memory,
hmm,
so that we first write it there and then have a thread who then writes to disk. So we can get a nice speed up with persistent memory. Uh, on the other hand, the patch that I talked about earlier that we will have in 12.3, that will be as fast as using persistent memory. But other things that we are using, for example, with vectors, we are utilizing different hardwares for Intel and AMD and IBM Power to get the maximum out of the hardware. We're also using the same thing for encryption um, and for checksums and so. So we are very focused on getting the best possible performance we can with reasonable resources.
perfect. Got it. Thank you. And Jignesh, also talking about the community, and we know that the community plays a vital role in any open source software. And just I want to understand now that you are a member of the MariaDB Foundation board member, right?
Yeah.
And
And CTO.
perfect. So, what's the role that Amazon is playing to impart the community and to make the innovation pace even faster?
Yeah. So in MySQL, I was disappointed when halfway through the MySQL um, story, the decision makers said that we shouldn't work with the community, we should just work with customers. And until then, we had been really, really active with the community and ensure that they were taken care of, and we would do reviews immediately. And that's kind of stopped for 3 4 years. So when we created MariaDB, I wanted to be sure that we don't do that mistakes. So very early, I created foundation with the goal of both protecting that the MariaDB could never be bought, and but the other part was to have a team who work actively on pull requests and get them in as soon as possible. So as Jignesh can know, we are really prioritizing that, and we have several people employed just looking at pull requests. And the MariaDB PLC has also people committed to look at any pull request that the foundation will give to them. So we want to have an active community and not having to wonder how can I get my uh, code changes in, which is a really big problem still in open source with most projects.
Yeah. I think just to add to what Monty said, right? Um, from an Amazon belief, I think a healthy community is where multiple organizations and code contributors can contribute to a open source project and see the value by those contributions being adopted, and it makes them feel part of that community. And as the community feels like your own, it begins to grow and thrive, and then a lot more people start using it. So as part of our diamond sponsorship for the MariaDB Foundation, I think I was happy to be kind of like nominated for the Amazon board seat out there. But like the goal is to kind of work with the MariaDB Foundation and especially with Monty to kind of like, drive those things that our customer wants to kind of see as a healthy community working with MariaDB. And to be honest, the conversations have been very active, going from measuring developer contributions that are happening across the board to hackathons to AI contributions that are happening in MariaDB, and also kind of a lot more that will be upcoming soon. So I'm kind of pretty excited with that.
Perfect. I just wanted to check if we have any comments from our viewers. So we have Silverbrea saying hi. We have Iri edits. Hi everyone. Hi Iri is one of the regular uh, viewers here. Data guy as well. And then hello from London, from Ireland. Sorry. And uh, there's a question just out of interest. How many active contributors do you have within the community? Do you have a figure for that?
Let's say full times outside of PLC or Foundation, we only have a few, but people who contribute from time to time, something like 100, and but everything is in the GitHub, so it's easy to see.
I see. Perfect. Also, Eric is saying greetings. Hi, Eric. So, okay. So, back again to the topics. So we covered the replication, and what else I wanted to cover is that the AI. Everyone is talking about AI those days, of course, and the database is part of this revolution, I would say. So how MariaDB is enabling AI for the end users or the customers?
So we were a little bit late to the AI train, so to speak, but working with AWS and other people from the community and PLC. Uh, in this case, I was using my foundation hat on. So we about in the beginning of the year, we released the first version of the MariaDB vector implementation, and we're happy to see that we are faster than any other open source database and faster than most of the so-called vector-only databases.
Mm.
And we are 10x faster than Postgres, PG vector, both, and notable faster both insert and select. And that just because we had the right people working on it. And it's also something that is native to MariaDB. So if you get the latest MariaDB, you will have it there already enabled. You don't need to load a plugin or compile anything. And we also have ensured that all the frameworks that is used by AI and also MCP and servers and everything else, we have MariaDB in there and fully supported. So we take vector seriously, but still we are an infrastructure project. We will not do applications around it. We have some of those done by SkySQL, but that's a different team. In this case, I'll talk about the server engineering team. We are just ensuring that you get the best performance and the best results that you can get. And so far, we are highly successful.
Perfect. And Jignesh, I believe with the integration with the other AI services that AWS is offering as well, that will be something that they enable the customers to innovate faster.
Yep. So, especially with the vector support in 11.8 for MariaDB, the vector data type is supported. I'm actually also happy to announce, I think earlier this month or just late last month, we also released the local MCP server for RDS MariaDB. So we extended the Aurora MySQL MCP server, which now with the direct database connection can also support RDS MariaDB servers. So together with the vector, with the local MCP server, we'll be continuously seeing more and more adoption of the AI integration with MariaDB out there. And we'll continue to kind of see those increase in the usage out there. the AI landscape is very evolving. So in this scenarios, we are also kind of like uh, we'll probably iterate few times to kind of like see how the usage by actual customers are shifting or changing, and we'll continue to kind of like iterate and kind of like make sure we are there to kind of address that out. But I'm actually pretty excited about the MCP server because that makes like the agentic AI being able to kind of like talk to the MariaDB server databases easily out there, and that should also kind of like spike, the integrations that we'd seek for MariaDB.
Perfect. Thank you.
So just a note, I was 4 days ago, I was in Thailand at the conference, AI conference, and we were there having a stand and um, talked to lots of users and possible customers. Um, we got most questions about how to move away from Oracle. If, we have kind of 12 possible customers who wants to do that, and we got 2 questions about AI at an AI conference.
Yeah, that's something I believe. Even that's what was going to be actually my next question to Simon. Actually, what are the patterns, the migration patterns that you are seeing for customers who are adopting open source databases, especially MariaDB? Is it a greenfield or just or customers migrating from commercial databases, as Monty was mentioning?
So I think there's kind of three main categories. You have people who currently use MySQL that want to migrate to Maria, oftentimes because of the more community-centered focus for MariaDB. You have the people who want to move from commercial to open source, whether that's MySQL or MariaDB. Those are probably the kind of main two. Generally speaking, I'd say if you have a lot of developers or DBAs with a background in MySQL or Maria, you tend to choose MySQL or Maria. The same for Postgres. I'm not saying there isn't people who move between them, but I'd say generally speaking, what's better between Maria and Postgres kind of boils down to like a religious question where you get people who fall on one side or the other, and neither side necessarily listen to arguments either way. So the movement between them is quite nominal. Commercial, the open source, definitely probably the bigger of the two.
Perfect. And Monty, you mentioned one of the features that you currently have on MariaDB, which is running the BLXQL code within the MariaDB engine, which might make things a bit easier for customers who aren't looking forward to migrating from commercial database to MariaDB. So can you please walk us through this feature, how it works?
Yeah, so this was part of me working with a bank in Singapore who had a mandate that we need to get rid of a big part of Oracle. At least we don't want to be dependent on it.
Mm-hmm.
So together with them, we created the Oracle compatible layer in MariaDB, where we just you set a variable, and then we will understand most of the Oracle common syntax. And we ensured that every syntax that the bank was using was supported with MariaDB. And this is all in the community server. And the end result was that after testing and checking this on some application, they moved 1,000 applications from Oracle to MariaDB in 1 year. 3 applications a day.
Wow.
Every day of the year. So we are quite compatible. It doesn't mean that we can everything, but we are working on more and more customers and adding everything they need into MariaDB. So we are putting a lot of effort to make us even more compatible with Oracle and other servers. So we also have SQL Server mode. It's very in its beginning, but it's a start.
Yeah.
We just need somebody who comes and said that we want to move and we want to move in the fastest possible way. Then we can repeat what we did with the Singaporean bank.
And I believe we have a demo for that as well, right?
Yeah.
Okay.
Very simple one.
Perfect.
Okay, so I just need to move to my terminal. So setting up things. So this is terminal. I have MariaDB server running here directly from the source, just compiled. You just go to the MySQL, SQL like here and start it. It's up and running. It's a debug version. But just because I'm a developer, I'm running that. And then we have a client connected to this one. So this is just a very simple demo that shows what we can do that some people have a hard time believing it's so easy. So let's I just very simple example, but just show the idea. So I start by creating a store procedure in MariaDB syntax. You can see that this is a in, out, EO. This is kind of the syntax. This is the in-out parameter. IO is the parameter and it is integer. And how it works, we set the variable to 1. We call the function, and then we print the result. We can see that the function changed to 1.
Yeah.
Or with 1. So if you want to do the same thing in Oracle, the syntax is slightly different. You are forced to have a create, begin, and end, but
yes.
also the in-out is differently. It's a different order. And of course, we can call this, and we can select, and you will see that this also works. But the interesting thing is the next example. So I'm still in Oracle mode. So now I create a store procedures that calls the one that is in ANSI SQL mode.
Okay.
And this works. So you can, and then also we can go back to normal mode default. We call this one, and it goes. So you can do one store procedures in Oracle mode, one in Maria or ANSI, and call them in any order. So this makes it very easy to port things. You basically take your PS SQL in Oracle and just dump them to MariaDB without any changes. And then when you do new code, if you are not going to use PS SQL anymore, you can do your new store procedures in ANSI mode, or you can start translating those one at a time if you want to. But there's no performance overhead whatsoever or having something in Oracle mode or not.
So it's not like there is a layer in between that translates from this syntax to the MariaDB syntax.
Yeah, so always when you have a language, you need to translate to your kind of inner code for handling that. The inner code is the same from Oracle and MariaDB. Exactly. So it's just the Yak who's doing that. So let's see. Okay. So here you can see that it says the procedure, there is somewhere said that this is Oracle mode there.
I see.
So we store it together with the store procedure, and then we interpret it. Another thing also that if you look at the Oracle mode, you can call. You don't need to use call as you have to do in ANSI. You can just have the store procedure just as a name. That's Oracle feature, and we have hundreds of syntax of Oracle syntax that we support, including packages and everything else. I mean, it has to be quite a lot to allow somebody to move 1,000 applications without doing any changes in applications except replacing the JDBC driver from Oracle's driver to us.
Definitely, yeah.
This was a short demo, but just to show how easy it is to move between the modes, and you can use those interchangeably everywhere.
Perfect. Thank you so much, Monty, for this. We only have 5 minutes left, so let me just, Jignesh, one last question about the challenges that when you are discussing the running the open source databases at scale, what are the challenges that the customers are surfacing when they are discussing this with you?
I think the the biggest challenge is providing a service around an open source product without changing the open source product. We
Yes,
aim to kind of like provide a bug to bug compatible with the open source bits out there, yet improve the experience for our AWS customer. So it's an interesting challenge on how you do that without really changing any of those compatibility expectations that the customer has. Now, this challenge also drives us to do innovations. The innovation happens surrounding the engines to kind of like improve that experience out there. But I think lately we've also taken an approach of working with the community to make it better overall for our customers. And a lot of those feedback that we hear from the customer is how we kind of like use that as a way to kind of channel into how we work with the community on what problems we want to address first as such. So it is always interesting for me to kind of like learn from these challenges and see how we can use that to work with the community. Also, end of the day, I think there are things that people want cheaper, better, and faster, right? So you continuously have to kind of like provide that continuously with every new version that comes from the open source community out there. And the good thing is you definitely get performance improvements with every version, which is good. AWS provides the newer generation of hardware, which are faster, which is good. And I think with the better performance, the overall price performance improves. So which it all works in the benefit of our customers.
perfect. Thank you so much. We only have 1 minute left. So, Monty, any final thoughts before we end the show?
No, and I think we covered the most of the interesting things, and so I
Thank you.
hope that the viewers agree.
Yeah, definitely. I'm sure of that. And Simon, anything before we end?
No, I think we covered kind of the main things. Hopefully, everyone enjoyed it. It's not often we get a legend,
Exactly.
but it's not an exaggeration to say we brought a legend along. So with that said, hopefully everyone enjoyed it.
Especially from my side, when I say like, out of the open source databases, MySQL, MariaDB, Postgres, 2 out of the 3, we have the creator out here.
Exactly. So, Monty, thank you so much for your time. Thanks a lot for being with us today. And it was really a pleasure having you, and we're looking forward to have you again and again in our show. Thank you so much for that. Same thing for Jignesh. Thanks a lot for spending time. I know you are super busy those days, so thank you so much. And Simon, thanks a lot.
No worries.
For all of our viewers, thank you so much for your time. We'll see you next week, same time. So, new topic, new also database related. So, see you next week. Thank you. Thanks, everyone.
Okay, thank
Have a good
you.
one.